This video will exhibit how easy the ARES 2 electrical resistivity meter is to navigate and use. The purpose of this video is to explain how to use a GF Instruments ARES 2 electrical resistivity meter. We will not be discussing the theory of electrical resistivity methods. Starting in the upper left-hand corner of the instrument panel, sockets C1, C2, P1, and P2. The outlet for the accessories, multi-electrode cable, VES and profiling adapter, and T-piece. LCD display. Power supply for a 12-volt car battery, battery pack, AC-DC converter, or AC adapter. Data transfer computer, USB flash disk, or GPS. Power output indicator. Stop button. Alphanumeric keyboard. Yes key. Arrow keys. No key. Select key. Measurement key. To turn on the box, press the green Yes key that says power. Manufacturing details will appear for a moment, then the main menu is displayed. The backlight can be turned on or off pressing the 0 or select key, or can be adjusted in the settings menu in the main menu. The No key powers the unit off from the main menu. We will now acquire data on the survey line that we set up in the previous video. We laid out 3 cables with electrode space every 2 meters. The total line length is 46 meters. Under the Continue Measurement heading, it is possible to open a previous file and continue measuring where it stopped. This option would be used in a roll-along survey that ended or if a profile needed to be stopped. From the main menu, select New Measurement. Select the type of measurement you intend to acquire. In this case, we will be collecting a 2D profile, so select 2D multi-cable. You will be given the option to copy settings from another file. Press the Enter key to select this option. Press the No key to create a new file without copying of settings. Copying settings is very handy when you are collecting a series of profiles with the same settings. File name. Enter your chosen file name for that profile. Optional input: locality, operator, note, and scheduled start. Optional menu. Profile number, set the X and Y positions profile, and direction. This is useful if your profile is part of a larger set of profiles. Next screen. Enter the profile length and electrode distance. The formula for the profile length is the number of cable sections times the number of electrodes on the section times the spacing between the electrodes minus the electrode spacing. In our case, we have 3 cable sections, 8 electrodes per cable section, and each electrode is spaced 2 meters apart. For a roll-along survey, if you only have access to 3 cables but wanted to acquire a longer length of profile, you can acquire a roll-along survey. In a roll-along survey, you enter the total desired profile length at the start of the survey. The ARES unit will recognize that the total length is greater than what is connected and will prompt you at the end of the initial survey to move the electrodes. The next screen will prompt you to select a method file. Choose the survey array of your choice. These are outlined in detail in the ARES 2 user manual. In this case, we will use the classic Schlumberger array. Note, HD in the array name means data will be acquired in higher density for a detailed survey. Select the proper method for your investigation and continue through the menus. The array settings. S-min, S-max, and zone shape refer to a depth range and shape. The S-min refers to the minimum distance between the first and last used electrode. Usually choose 0, the start from the surface, to maximize your measurement. You may want to increase your S-min to minimize your measurement time. S-max refers to the maximum distance between first and last used electrodes. Typically choose your total line length that have electrodes connected. If you are doing a roll-along survey, S-max will not be your entire line length. The next screen is to set the parameter optimization. Potential. You can set the minimal required potential to be measured. For most cases, 20 millivolts is sufficient. Stacking. This sets the number of pulses used for average value calculation. Consider increasing this number to improve data quality or decrease to collect data faster. Standard deviation maximum. 5% is sufficient. You can set the max standard deviation that you like, but this may impact your overall measurement time. Power. You can use this setting to limit the maximum transmitter power. 850 watt parameter enables full transmitter power. The next screen will report the outcome of your chosen settings. It will display the number of layers and points in section and the estimated time it takes to test. At this point, you can decide if this is sufficient. If not, you can page backwards through the menu and change the settings. If you approve the settings, you will be prompted to measure now. The unit will search for accessories and inform the user of the number of connected electrodes, the minimal number of electrodes needed for the measurement, and the position of the first electrode, which should be 0, unless using a roll-along method. If the number of electrodes is not correct, check that the cable connections are completed. Rough treatment of equipment can result in broken equipment. If all of the cable connections are complete, and the switch box is properly attached and the correct number of electrodes is still not connected, your cables may have integrity issues. If working over a road, large rock, or other obstruction that you cannot penetrate with an electrode, you can set dummy electrodes. The data will not be acquired from this electrode. Entering the position -1 indicated that the editing of dummy electrodes is finished. If you don't need any dummy electrodes, then just continue by hitting the Yes key. A screen saying Start Measurement is displayed and prompts you to insert the key to Unlock Stop button. Once the system is unlocked, the unit will begin the test of the grounding resistivity. Once complete, the ARES 2 will display the average grounding resistance. You can page through the list of electrodes with arrows to see all of the electrodes with ground issues. If outliers are present, the electrode may need adjusted or rehammered. Readings of greater than 999,999 typically indicate an electrode that is disconnected. A bad connection can be the result of dust or weeds between the outlet on the cable and the stainless steel stake, or a bad contact between the stainless steel stake and the soil, or of a broken rubber O-ring. You can start the measurement once all positions display an acceptable good grounding resistance. Press the Yes key on the line, All are OK, Start Measurement. The red LED diode is blinking during the measurement. The next video will briefly review, tracking the data as it is acquired. The ARES will beep when the measurement has ended, and a new screen will appear showing the data. Pressing the Enter key will save the data. THG Geophysics is the US representative for GF Instruments. Please contact us directly for more detailed equipment information and pricing options at www.thggeophysics.com.